Welcome to this video demonstration that I recorded to demonstrate the features of IQVIA's Snowray terminology service in response to an RFP about the provision of a health data dictionary to the CSIR in South Africa. We have a terminology service that's running as a public instance for demonstration purposes, and this is what I'm going to use to show you some of the functionalities. In order to access this service, I need to visit snowray.app, and you are free to try and register a free user account and follow along or look into some of the capabilities. If you'd like to read more about Snowray, you can browse this website or you can go straight to the web application, and that is where I'm going. I'm already logged in. Authentication is provided through OutZero. You can use some of the social identity providers as well to create your free user account. After logging in, we're looking at the dashboard now. Now this is a web application, but in the backend we have a terminology server. It's called the Snowray terminology server. It is used across the globe to maintain different healthcare terminologies, including SNOMED-CT extensions, local codes, different mapping sets, value sets, and other standards that are specific to a particular country. The Snowray terminology server is a revision controlled database which enables the management, the authoring, and the publication of these different terminologies. Now let's take a look at the standards that were requested specifically in the proposal. From the dashboard page, where I can have a glimpse of my resources and an overview of my team's daily activities, I'm going to navigate to the resources page, which is a more dedicated view for the different terminology assets. It's more similar to a file browser. I have my private space here, but I'm going to switch to my B2I Healthcare Company portal, where I can access some of the standards that were mentioned as core requirements. Now let's start with the first one, SNOMED extensions and SNOMED editions. I have a bundle where we've imported almost all the publicly available SNOMED-CT country extensions, and they can all be browsed with the system. If we select the international edition and double click, we can take a look at the content in a hierarchical view. So SNOMED-CT concepts are organized into this large hierarchical structure. And if we select a particular concept, we can look at the properties, including metadata about versioning or the concept maintainer itself. So concepts have their effective time and their status that indicates their version. The concept ID is the unique identifier, and the module gives us more information on who's maintaining this particular concept. Now this is the international edition, so everything is going to be SNOMED core. Concepts can have different descriptions in any languages, really. The international is in English, but we can have a look at some other country editions where other languages are represented. And concepts can have properties that are relationships pointing to other concepts, and we can follow these relationships to traverse the graph of SNOMED-CT. Status and versioning information is available application-wide, and if a new version of a SNOMED edition comes along, an administrator user or a user with proper access rights can import it from the standard RF2 format. Different versions are maintained in the system, and you can always go back to browse earlier versions of SNOMED. A few words about searching content. So you can do basic lexical searches, for example, to retrieve concepts that are related to myocardial infarction, or you can take a look at this advanced search pane to see what other search options you have. For example, you can search by metadata. You can restrict your results by hierarchies by selecting a particular ancestor concept. You can apply different semantic tags to further constrain the result based on the domain. And the most exciting search functionality that was introduced by SNOMED-CT is something that's called the ECL, the Expression Constraint Language. This is a semantic search language which we extended to work not only on SNOMED content but on any other terminologies. I will have some examples of that later on. Let's take a look at some of the other standards in my workspace, so see what kind of ICD contents we have here. The requirements state that we should support the South African edition or modification of ICD-10. That's not something that we have in the system out of the box, but we commit to importing that during the deployment phase. We do have some other ICD-10 country editions imported already because it was requested by some of our customers. So we have the French edition, the German edition, the Swedish one, and the clinical modification, and the core ICD-10, which was published by WHO. If you click on this ICD-10, you can see the metadata, or you can navigate to the content page, where similarly to other terminologies or other classifications, there is a hierarchical structure, and you can view the details on the right-hand side if you select a particular code in the hierarchy. Sometimes details are rather verbose, sometimes they are more compact. Searching on ICD-10. Now, properties are not very common in ICD-10 yet, so here we provide two different search options. One is to search by term, but that also accepts the code, so you can search by code or label, or you can use this expression constraint language and search by hierarchy. The third international standard that I wanted to cover was LOINC. So similarly to other terminology standards, you can access LOINC 2 and browse it in a hierarchical manner, where the browser part is on the left-hand side, and on the right-hand side you can observe the details of the different LOINC parts or the different LOINC codes. Searching, again, is based on the term, which also accepts the code, or you can filter by the hierarchical structure. The version of LOINC that we currently have in the system, I think it's 273. We have some earlier versions as well, where we can go back and browse them, and we can import any newer versions as well. It's just, this is a server for demonstration purposes, so obviously here we don't do too much of the content maintenance. Now, these are some of the standards. They can be imported into the system from their standard serialization format. So for SNOMED it's RF2, for ICD-10 it's CLAMO, and they can be browsed, or they can be used as a basis for building derivative content. And this takes us to the third types of resources, which are defined by the FHIR specification. I have some examples here that I will go through. So the FHIR terminology service specification describes three different resource types: code systems, value sets, and concept maps. We support all three of these. These can be imported from the standard FHIR JSON format or from other formats, like for the code system from Excel or CSV format, or these can be built by this web application from scratch. I have an example for that I built from scratch. This is a code system with 32 codes. I have been building it for quite a while now, as you can see, and the system logs all user edits with the date and with information on who made the change and what the changes were, so it can be tracked back. This resource also follows a similar revision-controlled versioning mechanism as SNOMED City. Throughout the years, I had multiple different versions. These could all be reviewed here in the system, and of course, I'm always working and editing the latest, most recent version, and that's what I have here as active. I can work on my own, or I can collaborate with other users, and that means I can invite them to have access to my resource. Our terminology service enables the configuration of different user access rights based on their roles. So their roles could be reader or maintainer or writer. And we have some explanation on the types of operations that these different roles can access. I can configure these access properties on every resource, so I can decide whether I would like to invite an organization, a team, or a single user to have access to it, or I would just like to keep it to myself for authoring. There is an other property to set on a resource, and that's the visibility. I can set it to public, so it's available for all users of the system, or I can keep it as private, so it's only visible for those that I am explicitly sharing this resource with. To facilitate collaborative work and teamwork, we integrated a very lightweight issue tracking system, which enables users to communicate on the resource and provide feedback to each other or log new work items. And we have the metadata here, which is available to capture for all of the resources that we have. So this is the last tab that we haven't looked at. For code systems, we allow the users to define a logical schema and enrich the semantics of their code systems with additional properties of different types. I kept it very simple, but my kidney disease code system uses one Boolean property on the codes, which is to describe whether it's something that's acute or not. And here is an example for where this property is set to true. For code systems, there is this hierarchical browser, and as well as for other terminology standards, we have a detailed page where we can take a look at the different descriptions and other properties like hierarchical relationships or properties defined by the schema. Once I'm done with editing and versioning, I can publish this code system by exporting it in Excel or by syndicating it to a runtime terminology server, which means that I'm automatically pushing the content to a distribution server, or by exposing it on the API. I will have some more info on the APIs, but first I would like to cover the two other resource types. Value sets. Value sets are collections of codes that could be built from any code system. It can be a standard, like SNOMED. In this case, the value set is called reference set. This is an example for a SNOMED city ref set, which is query-based. It is using the expression constraint language to define a query expression, and the members of this set are the results that are matching this query. So in this case, we are collecting all subtypes of clinical finding that has a finding site in the kidney structure or any subtype of the kidney structure, and it resolves to this list of concepts. For value sets, we have the same sort of maintenance mechanism as for code systems, with the difference that value sets and mapping sets have dependencies on other code systems. So here we introduce an extra additional feature, which is a semi-automated way to upgrade this. So my underlying code system, SNOMED City, had a new version, and I get an indication that my value set needs upgrading to this new version. I have a few of these resources here. And this one is easier probably to demonstrate. This is a value set that is built on my kidney diseases code system. It is in upgrade, meaning that I have already started to look at the version differences between version 3 and version 6 of my original code system. I evaluated the query expression in the value set and found that there is a new member that could be added to this value set, and I get this report here, and I can accept adding this new member, finish upgrade, and this is the end of my maintenance cycle for this particular value set. So we were looking at value sets that were built based on SNOMED City, value sets from local codes. These were all query-based, but value sets could be defined not only by a query expression, but by manually selecting codes from the hierarchy as well. These resources can be created from scratch. So if I click on new resource, I can define what type of resource I would like to select. populate some metadata and start building my code system value set or concept map or refset collection. The third Firebase resource type that I wanted to cover was the concept map. This is an example for how we are trying to map from a set of local codes to an international standard. The reason to do this is to facilitate the standardization and therefore to improve or contribute to interoperability, because very often clinical notes are captured using some standard, non-standard or local code system, and in order to make it readable, we need to standardize the data using these maps. These maps can be built manually, and the system provides a number of automations to improve this manual mapping process. For example, automatic mapping based on lexical match, or automatic mapping based on semantic similarity, which is a bit more AI focused and provides more accurate search results and matches than the simple lexical searching. Similarly to other resources, all the revision controlled features are available. Revision controlling, version tracking, sharing the resources are available. It's possible to log tickets for users that want to collaborate, and these maps can too be published. These are the three resource types that I wanted to show. We were covering the search capabilities, we were checking out the user interface, the versioning mechanism. You can always see already on the resource browser the particular version that the resource has, the status of the resource, and its life cycle, whether it's still draft or it has already been published and it's active, or in case it's retired, then that it's retired. You can see whether it's public or private, if there is any upgrade that you need to look out for, and an approximate size of or volume of concepts within that particular resource. Just a few more words about organization and team support. So I have my user profile here, but I also belong to different organizations. As a user, I can have my own resources. I have access to my organization's resources too. And within the organizations, it's possible to create different teams that are focusing on different work items, and user access rights can be configured on a team basis as well. I have a notification view to see some of the changes that are relevant because they're from my organization or working on content that I was involved in too. And for more detailed information and documentation, you can always go to the help and open the user guide, where you find really detailed information on how to use the system and what features are available. One last thing about the server API. So the terminology server that is in the backend, it comes with an API. It comes actually with a number of APIs. There is a standard Fire API, and also there is a proprietary REST API. We provide information on this in our proposal response, but you can take a look at the different APIs and the different operations here in this API documentation too. Thank you very much for watching it, and feel free to explore on your own by visiting snowray.app. Thank you.